Hello viewers, welcome to this exciting video. In this video, we will be looking at the November 2021 Science Paper 1, question C3. Now, why have I chosen to come and start doing question C3? The reason is simple. There has been an urgent need of people to improve their graph plotting skills. So I've just dedicated the next couple of videos towards graph plotting, and all the videos that you see in Science Paper 1 from now on up to, I think we've done up to the time we'll do 3 or 4 graphs, a revision of papers dealing with graphs, 3 or 4 of them. Then we can continue with these other things. All right. So, question C2 reads, the following data was obtained from an experiment to determine the focal length of a biconvex lens. The following data was obtained from an experiment to determine the focal length of a biconvex lens. All right, so here the main focus is to determine the focal length, okay, of what? A biconvex lens. Now, if we do understand what a biconvex lens, then we actually know what we're really talking about. However, if you don't know the type of lens, there is no need to worry. This question does not require you to actually illustrate how this kind of lens looks like. All right, so we have a table here. We have a table, and in this table we have measurements, and we have u. We have u. U is measured in centimeters, and we have 30, 35, 40, 45, 50. So if you critically analyze how these values are increasing, it's almost like they're increasing every after 5 centimeters. So from 30 to 35, 5 centimeters, from 35 to 40. So this gives us, it lightens the load that we have, as you will see when it comes to the actual graph plotting. So what does U stand for? So these values, U, are for the object distance. Object distance. Object. How far is the object from the lens? How far is the object from the lens? These are the readings. While V stands for image distance. Okay, image distance. Others may ask, but how did you know that U is object distance and V is image distance when they've not told us? Okay, the simple fact is that in most cases in science, we follow a pattern of what comes first and what comes last. So for you to have an image, you need to have an object first. So the object comes first, while the image comes second. Now, if we follow the position of these letters on the alphabet, you find that U comes before V. So U comes first and V comes later. So a simple illustration will be the last few letters of the alphabet will be R, S, T, U, V, W, X, Y, and Z. So you see U comes first, then followed by V. So object, you need an object to produce an image. All right, so let's proceed. All right, so we've got object distance and the image distance. All right, so then we have this part, which is magnification. Now, magnification, we've been given a formula. This is a formula and not units. This is a formula for how to calculate the magnification, which is V, which is image distance divided by object distance. Now, because both of these are in centimeters, therefore the magnification will not have any units. So magnification has no units. in this particular case. All right, so they're saying for A, copy and complete the table to get all the values of M, which is magnification. Copy and complete the table to get all the values of M. So I will not really copy the table, but I will answer, I will fill in, uh, I will fill in the values of the magnification just from this table. All right. So how do we do it? They're saying it's V divided by U. So V divided by U. So we're going to start. The first value will be 44 divided by 30. So what is 44 divided by 30? 44 divided by 30. So we have 1.46667. Now, our graph at some point will be required to plot. As you can see, there is part B, which is plot the graph. Okay, so I do not need a lot of decimal places, okay, because that will be difficult for me to plot. So I want to make it as light as possible. So I'll only pick my values will only be to one decimal place. So I'll have 1.5 as my first point. Remember, the number of decimal places you choose should go throughout the values. So I'll have 1.5 as my first value. Then I go to the second. The second is 37 over 35. So 37 over 35. 37 divided by 35. 37 divided by 35, which is 1.1. So 1.1. So I have 1.1 there. Then I have 32 over 40. 32 over 40. 32 divided by 40, which is 0.8. Okay, so 0.8. Then I have 31 over 45. 31 over 45, which is 0.7. 0.7. Then 28 over 50. 28 over 50, which is 0.6. 0.6. So I have those values. Just for doing this, I'll get my 2 marks. All right, now we come to the core business, which is plot a graph of M against V. Plot a graph of M against V. So M against V, what this means is that M should be on your y-axis. So here we'll have our M. Here we'll have our M. And on the x-axis, we are going to have our V. Okay? Now, I think let's get to our graph paper. Let's get to our graph paper. Now, before we even go there, I'll need to carry the values with me. I'll need to carry these values with me. So what we're going to do is, there are our values. Okay, allow me just to do that. Then let's go to our graph paper. Now, sorry to present this question on a graph paper that is literally different from the one you're going to use in the exam. However, I've tried to search for a graph that almost meets those standards, but all that I've been finding is that most of them do not conform to the standards of the exam. So this is what I came to be as close as possible to the graph that we use in our exam. All right, now what we need to know about plotting a graph, other than just having these values with us, is that one, every graph that you plot should have a title. Every graph that you plot should have a title. And already they've given us the title. The title of our graph is supposed to be M against V. M against V. So that is the first thing we are going to write on top of our graph paper. So we are going to have M, which is capital, against V. Then, because there are small letters there that I've used, I'm going to underline that. So that is my title. Away from the title, you've just done one thing. Away from the title, you should draw the axis. Okay, draw the axis that has already been done for us at this particular point. Now, these axes at the end, they should have arrows. Now, where do you really draw the axis? For me, I advise that at the end of your first box, which is this box, at the end of this box, so the first box, this is our first box, where it ends, that is where you draw your x-axis. And where on your y, at this particular point, that is where you draw your y-axis, so that it is as close to the bottom as possible, but leaving space for you to write whatever you're supposed to write there, and also leaving space for whatever you're supposed to write there on the y-axis. I hope we're together. All right, having done that, so they should have arrows. So these axes should have arrows. All right, so I've placed an arrow on the x-axis. I also need to place an arrow on the y-axis like that. Then what should follow is that these axes should be labeled. These axes should be labeled, and the label of each quantity you are going to place on that axis should have units. Okay, so we are saying it is M against V. So V, as we can see from the table, V has got units of centimeters. So I'm going to write y on the x-axis, it's V, and it is in centimeters. V in centimeters. Wow, on the y-axis, what we have is M, and M has no units, because when you divide centimeters and centimeters, you are left with nothing. So on the y, we are going to have not V, we're going to have M. So on the y-axis, we're going to have M, which is a capital letter M, with no units, So once you do that, okay, be rest assured that you have gotten your first mark. Now remember, you've not done anything. Okay, you've done something, but in terms of plotting, okay, people will think, "Oh, once I start putting those points and everything, that's when I start scoring mark." No, just for writing, for drawing these axes with arrows, okay, and writing that title, labeling the axis with the correct units, okay, scores you 1 mark out of 4. So you have 1 out of 4. The next stage involves you coming up with the appropriate scale. Now, the appropriate, or the scale you're going to use, should ensure that your graph covers at least 3/4, 3/4 of the entire graph paper. Okay, now at some times examiners will become so lenient that they will accept one candidate who has plotted a graph that occupies more than half. Okay, at this particular point in time, even a small graph will score as long as it is bigger than half of the whole entire graph paper. Now, how does this basically happened? How do they know that this is 3/4 and what is the graph? Because others will say, as long as your numbers on both axes are span out as wide as possible, then your graph is occupying more than 3/4. No. Okay. So if you look at what we have on the x-axis. On the x-axis, we have v, which has values from as low as 28 to as high as 44. It means that the distance between your first point and your last point should be as far apart as possible, such that they occupy the space between them is more than 3/4 or is more than half. All right, maybe talking too much is a bit of a challenge. So the standard graph paper that you're going to have may have about 10 boxes on the x-axis. Now, 10 boxes, it means that your graph, the distance between the first point, which is 28 and 44, should not be less than 10 times 3/4, which is basically 7.5. Now, in this particular case, we round off to the highest, so it should not occupy less than 8 boxes. Okay, it should not occupy less than 8 boxes on the x. However, if we go with the half, it means that it should not occupy less than 5. So always look out for, on the y-axis, the distance between your first point and the last point should not occupy less than 5 boxes. Less than 5 boxes, please. They should not. Now, to ensure that that is achieved, what do you do? Oh, so we have 28. Your graph does not necessarily need to start from 0. It can start from the same smallest value. In our case, it's 20. It's 28. So 28. Okay. So I'll place my 28 here. I'll place my 28 here. So here, this is 28. Then what I'll start doing is that I'll start increasing this. Okay, I'll start increasing this so that my 44 should be somewhere above, somewhere here, or moving forward. Remember, I have 1, 2, 3, 4, 5. So the number of boxes, so 44 should not come before this point. 5, 6, 7, and I have 8 there. So it should not be before the 5th mark. Okay, should not be before the 5th mark. So what I start doing is, this one may be relatively easy, but I would also recommend somebody just doing just a simple mathematics. You say 44 minus 28. Okay, then how many boxes do you want? I'll say 7. Okay, because 7 is more than 5. So I'll say, okay, 44, clear, 44 minus 28, which is the biggest value on the x-axis minus the smallest value. So I have 16. 16, if I say 16 divided by, let's say 7, okay, 7. So divide by 7, because I've already used 1. Okay, so when I say 7, it is actually 8, because the 28 is on one of the points. So this is 2.2. So I round it off to the nearest whole number, which gives me 2. So I come back to my graph. Then I'll say, okay, 28 plus 2, which is 30. 30 plus 2 is 32. 32 plus 2 is 34. 34 plus 2 is 36. 38, 40, 42, 48. So if we count 1, 2, 3, 4, 5, 6, 7, 8 boxes have been used. Okay, 8. All right, not 48, sorry, it's 44. So 44. Then I move to the y-axis. To the y, I also almost just do the same. The y is m. So I have the biggest value is 1.5. The smallest value is 0.6. So I'm going to say 1.5. 1.5, okay, minus 0.6. So I have 0.9. 0.9, even on the y-axis, the minimum boxes I'm supposed to use is equally 8. So I say, okay, this divided by 8 or by 7, okay, by 7. So this gives me 0.1. Y7, I've already used 1. That is where my 0.6 is going to be. So I have 0.1. So 0.1 is the number I'm going to get, because this I cannot say to the nearest whole number, okay, because I already have 0 and these are increasing by 0.1. So I'll have 0.1. That will be the value I'm going to use to increase. So here I'll have, on this line, I'll have 0.6. So 0.6 plus 0.1, I'll have 0.7, 0.8, 0.9, 1.0, 1.1, 1.2, 1.3, 1.4, 1.5, okay, 1.5. All right, now I'll just zoom out so that we can see how our graph looks like. So, and all right, so on the y-axis, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I even have 9. I've used 9 boxes out of, for a standard graph paper that is going to be used, there are 12. So 9 out of 12 is more than 3/4. And I already have my first and last points almost already plotted. Then I zoom back in. All right, so now at this particular point, remember the distance between, you can see that if I say 0.7 minus 0.6, I'll have 0.1. 0.8 minus 0. I'll have 0.1. It's 0.1. It's increasing by 0. If ever there is a time when the difference between the number coming before a certain value is less or is more than what we've been using to as the value which is increasing, is not consistent. There should be consistency. If there is lack of consistency, everything falls. Remember, lack of consistency will make everything to fall off. So now, once you do this, it means that on the y-axis, you are using 0.1, okay? 0.1, 2 centimeters to represent 0.1, okay? And that should continue. So for every 2 centimeters, there is an increase of 0.1. On the x-axis, for every 2 centimeters, there is an increase of 2 centimeters, okay? So that is our scale. You don't need to write it like in mathematics. You don't need to write it. Here, just doing this means that your scale is correct. Now, for a scale, so at this point, what we said is that for correctly labeling the axis and the title, you have already gotten your first mark. For a consistency in the way the numbers are increasing on your on both axes, okay, scores you another mark, which comes, this mark comes from scale, okay, scale, okay. Now the scale also will go with the size of the graph. Now let's go to the size of the graph. So let me remove this mark because it has not been fully ended. So All right, so we now go to the actual graph plotting. Now, in science, there are two ways in which we can denote a point. A point can either be noted by a dot, okay, by a dot. If I put a dot there, it should be circled, okay. Now, the size of the circle, it's only that my screen, okay, my screen cannot allow me to draw a very small circle. It should not be bigger than one of these small boxes, okay. Now, if you don't want to use a dot, you use a cross. Now, even the cross should not be bigger than that box. So we should always make sure that our pencils are sharpened, but not too sharp so that they pierce the graph paper, or they punch the graph paper. So we can start. So the first point is 44, 44, 44,1.5, which is this one. So this will be our first point, 44,1.5. So we'll go to where this is 44. So we'll follow this 44, we'll follow it, and make sure we find where it meets 1.5. So this is where 44 is meeting 1.5, and I will circle it. This is my first point. So this point is gone. The second point is 1.1, 37, or 37,1.1. 37,1.1. So I come back and I look for 37. Where is 37? 37 is exactly between 38 and 36. So this is where 37 is, and I will follow this until where it meets 1.1, which is here. So this is the other point, okay. Then the next point will be 0.8, 32, 0.8, 32. So 32 is here, 32 is here, okay. 32 is there, and it is going with the 0.8. So 0.8 is right here. So 32 is here, 0.8 is there, okay. All right, the next is the next point is 31, 0.7, 31, 0.7. So 31, where is 31? 31 is between 30 and 32. So 30 and 32, and this is the point, and it comes here, and it is like that. Then the last point is 28, 0.6, which is just at our starting point, just there. So now, okay, allow me now to zoom out. So once you've done that, okay, once you've done that, okay, you will get a mark for correctly plotted points. Now the graph spans from where you started from where we started from, which is this point, to the smallest or the last point, which is this point. So what we now need to do is connect with a best fit. You can see that this is a straight line. This is a straight line. We are going to connect those with what is called a best fit line. Never should you try to start joining the points individually together. There are only two types of graphs. It's either it's linear, it's straight, or it's a curve. If it's a curve, you follow. Okay, there will be points that will not fall on the curve or on the line. It's okay. They are called outliers. It means they are as a result of faulty or errors in the data collection. All right, so we are going to now join these points. So from the first point, I will draw a line pass. No, 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 no. No. Yes, it has passed through the first, the second, and the third line, but I can see that it also wants to pass through the second point. So the reason for the second is that it gives you an error margin where your results will still be acceptable. So let's try that again. All right. All right. It seems as if my equipment is failing me. Okay, let's try that again. All right, better. This is better. So you can see that it has touched the circle on the third point. It has passed through this point and it is touching that point. So this is the best fit line, the line that passes through most of the points. So this point which has been left alone, this we can say is an outlier. Okay, this is an outlier. We zoom in again. We zoom in. So we can see how our graph looks. It is passing through the first point, not the second. The third point it's touching. Okay, the fourth point there and the last point there. So for just this correctly plotted points and smooth curve, your line should be smooth. So at this point in time, if you are wondering about marks, you should have gotten about 3 marks, or not 3 marks, or the 4 marks. So for correct scale, you get your 1 mark. Okay. Okay, so you get your mark for correct scale and size of the graph. Then for correctly plotted points you get, and for the smooth curve you get. So those 4 marks are just for doing this. Okay, are just for doing this. Then let's proceed and check out the next question. The next question is say determine the slope of the graph. Determine the slope of the graph. Now, to determine the slope of the graph, you choose 2 points that are as far apart as possible. And in most cases, it is advisable to pick on points that are not part of the points that you've been given. Okay? Now, so for us to do this, we need to select 2 points. For me, I think what I'll do is let's see which points can we use. All right. Okay. We will pick on this point, this particular point. Okay. We'll pick on that point. So this is the point we are going to use, and I will draw a dotted line like that. Then let's search for another point that we can pick, and I think we can also use this point there. Okay, so I draw a dotted line coming so that the 2 lines should meet. This is important. This is important. So just like that. So you can see it's more like a triangle. Okay. Now I'll do all my calculations right here on the graph. Okay. So here I have this as the value. Okay. Then here I have this as the value. Okay. Okay. Now, I know I've picked on points that are relatively a bit difficult to actually find, but anyway, we'll get through that. All right. So what I'll do is for this one, it's this point and this point. All right. So now, gradient in mathematics is represented as g, But here we've been given that the gradient should be g. So I will now say g is equal to the change in m, change in m over change in v. So this is equal to m2 minus m1 over v2 minus v1. So as we move from the starting point, which is this is our first point, and this is our second point. So whatever coordinates we get from this one will represent the 2's, and whatever coordinates we get from here will represent the 1's. So let's start with m. What is the value of m2? The value of m2 is 1.3. So g is equal to 1.3 minus, what is the value of m1? m1 is here. So we know that from 0.6, after 2 centimeters, we've got 0.7. So this point will be 0.65. 0.65. So 0.65. So we have 0.65 over. All right, we come now to this one is our second point. So this is 40. Okay, 40, and this is 41. Okay, so it means that it's increasing by 2. So this is 40, this is 42, this is 44, this is 46, 48, not 40, this is 40, this is 40.2, this is 40.4. So this is 40.4, 40.6, 40.8, then 41. So 40.4. So we have 40.4. So 40.4 minus. Then we come on our first here. This is 28. This is 29. So this is 29. So 29. So we have 29. So there we have it. So we are going to have 1.3 minus 0.65. So 1.3 minus 0.65, which is 0.65. So 0.65. So we have g is equal to 0.65 over 40.4 minus 29. 40.4 minus 29, which is equal to 11.4. 11.4. So 11.4. So 0.65 divided by 11.4. 0.65 divided by 11.4. 0.65 divided by 11.4. Is it? Yes, 11.4, which is 0.05, 0.057 or 0.06. So 0.06. So g is equal to 0.06. What will be the units? M, remember, on top, no, we don't have units, but below we have units. So it is going to be a centimeter to the power -1, or per centimeter. That is our G. So for doing that, you score another mark. All right, let's get back to the question. So they're now saying use G, use the slope G of your graph to determine f, which is the focal length of the length. And we've been given G is equal to V over f minus 1. So G we know that they're saying G. Now they want us to find the focal length. So we need to make F the subject of the formula. So what we're going to have is we're going to have G plus 1 is equal to V over F, okay, meaning that F is equal to V over G plus 1. So this is the formula we're going to use. F is equal to V over G plus 1. F is equal to G plus 1, V over G plus 1. So we are now calculating the focal length. So even the focal length, we can calculate it from here. So we know F is equal to V over G plus 1. So F is equal to, what is V? What is V? V, which is the image distance, okay? Okay, so any, you can pick on any of these. So we pick any value of V, okay? We pick any value of V. So we can go with the 44. So we'll have 44 over G. What is G? G is 0.06. So 0.006 plus 1, which is 1.06. So F is equal to 44 over 1.06. So F is equal to, so F is equal to 44 divided by 1.06, which is 41.5. 41.5. So which is 41.5 centimeters. 41.5 centimeters. All right, this brings us to the end of this video. If you like the video, don't forget to give it a thumbs up. Thank you very much.